Okay, we're going to focus on ocean water now. We talked about that fresh water is only 2.5% of all water on Earth. 1% of that is surface water, so a very small percentage of fresh water. Most of the fresh water we said was frozen. Now all the rest of that water on Earth, 97.5% of it, will be salt water, will be found in your oceans. You do need to be aware of your oceans. The Arctic, make sure you know Pacific Ocean is the west coast, Atlantic Ocean is the east coast. We'll be talking about that a little bit as we're talking about different currents. What makes it salty? What makes it so salty? Make sure you're aware that a large majority of your salt water is chlorine and sodium. Then we have your sulfates, magnesiums, and calciums. Now these salts can be diffused into the ocean many different ways. This can be through acid rain. So a lot of the salts are being diffused into the ocean water because of all these different minerals already being in the ocean floor or in the rocks there. If there's any underwater volcanoes, because we have plate tectonics, and as we have the different rifts between plates, you also have all these rivers and streams dropping off sand and different particles and different minerals as well. So as we just said, why is the ocean so salty? There's many different minerals coming in from different places. Okay, as you can see in the picture, okay, acid rain, volcanoes, the ocean floor, minerals being dropped off from rivers and streams. Now here's a term you need to know. This term is called salinity. This means how much salt is in the water. Now you can go through a natural evaporation process, and that is called distillation. If you ever bought distilled water, that means that they removed the water from the salt water. So they evaporated, maybe in a mechanical process, they evaporated the water, leaving behind the salt. And another name for distillation is desalination. Okay, so we're taking away the salt. Here you have the word salinity in desalination. A natural distillation process is evaporation, with the sun evaporating and turning liquid water to gas. It's removing the water from the salt. Now we're going to move into some patterns of water movement. The first one is waves. Waves are a rhythmic up and down motion. Waves are going to be formed from energy, the movement of energy as it's transferred through the water. Wind is going to impact that. That wind energy is going to create these waves. The larger the wave, the greater the wind speed. You have the top of the wave, which is called the crest. The bottom of the wave is called a trough. Now think of a pig trough, kind of like a manger where food would be placed in. It's dipping down so you can put the food in. So a trough is the bottom area. And what we have here is when we measure from trough to crest, that is the wave height. When we have crest to crest or trough to trough, that is wavelength. Now, when a crest gets too high, the wave will tip over, and that is called a breaker. That's usually what we think of when we see this big curling wave. That's actually a breaker. The up and down is called a wave. Okay. When a wave gets closer to the shore, usually the wavelength will decrease, the wave height will increase, and then that will cause that breaker as well. Now, as you can see, the different waves are moving. Now, remember, waves are a rhythmic motion, and up and down. So technically, if you look at the little seagull there, the seagull will not be moved from that point to the shore. The seagull will just be sitting there moving up and down according to just the wave. Now there's currents that will move water, but we're not talking about what's going to be happening here with waves. Here you can see the waves, the energy is being moved, but yet the ball does not go to the shore. The ball is just moving up and down, being kept in the same place. Now this is an animation. Here's another animation. As you can see, okay, as the wave energy is being moved from left to right, the object, however, does not move left or right. The object just follows the wave up and down, crest to trough. just being recycled, moving up and down. But does this happen in real life? You can see that energy is going to be moving from one side or the other. We're creating waves. What's going to happen when we put a ball in that water? Is the ball going to be moving from right to left? No, the ball is just going to be recycled up and down. The energy is being moved here right to left. Energy is going to be transferred from one part of the water to the other, causing the water to move up and down, but the water is not moving from left to right. Now, a current is the movement of water. So make sure you understand that there are many factors here that cause different things to happen in the ocean. The movement of water, a combination of waves, which is energy or wind energy being transferred, compared to a current or an actual movement of water. The size of the wind generates waves. We talked about that. The faster the wind, the higher the wave will be. So wind speed, wind direction, how long or the length of time the wind blows. And then the fetch, which is basically the extent of open water across which wind can blow, so how much water the wind can blow on. It can shape coastlines. It can erode cliffs, this constant up and down being pushed and hit on rocks, causing erosion. Ecology, it will return oxygen to the water. It can stir up food from the bottom. There are 4 types of waves that you need to know. There's the very small waves called ripples. Now, ripples are also called capillary waves, and if you think about what capillaries are, those are your very tiny blood vessels go into your tiny little cells, so they are the smallest. Small waves. Waves will start out very small. These are the first waves when wind will blow over a surface, could be caused by a vibration, maybe even a little earthquake. Maybe someone stepping into the water. It can be caused by wind or you blowing on the water. A chop, this is when basically you start off before a storm. The water starts getting choppy. These are small waves showing that the ocean surface is going to be rough. Then we have a swell. A swell is usually after a storm. When the storm moves out, these waves start spreading out, and they're pretty balanced on how far away they are. So it looks more tranquil, more relaxed, and they have similar wavelengths. Remember, wavelength is crest to crest and trough to trough. Then we have breakers, and we said a breaker is when that wave height gets a little too high and tips over and falls. So that's a breaker. So let's look at some pictures. Here you can see the wave motion. The energy is going to be moved. So here's a ripple. Here's the choppy water before a storm or the wind speed starts picking up. Here's a swell after a storm. You can see the wavelengths are pretty balanced. And here's a breaker, tipping over of the wave. So make sure you know those. You're going to see those pictures on your quiz as well. Okay, you do need to know what a tsunami is, or called a harbor or tidal wave. A tsunami is a wave. It is not a tide. So basically an earthquake will cause vibrations to come about. It will push the water, and here's the problem. When it gets too close to the surface, it's too much water, and it will actually get pushed through. We usually think of these huge giant breakers. That's not usually the case. It's more like a giant push or flood of water coming too fast. Many times you may see when the earthquake happens, there might be a sucking back of the water, and then the water gets pushed. Now, if someone was right above that earthquake in a boat, they would not be really influenced. They would not be capsized by this. The tsunami is when you have push of water. The land that's holding the water is getting smaller, but we still have so much water being pushed in that smaller area. That's where we get this giant flood of water. So you can see that here with the tsunami, we have this giant push of water in a smaller surface area. Currents are a movement of water. It's a circulation of water. This is caused by wind and the rotation of the earth. So make sure you write down that currents are the movement of water. Waves, not the movement of water. This is the transference of energy. That was waves. Currents will be the movement of water. Okay, so wind, earth rotation, and density changes. Okay, here's the earth rotation. This is actually called the Coriolis effect. You can see that as you read through. But when we're focusing on water, we're talking about now the movement of water, and these ocean currents can be focused on wind and the tilting and rotation of the earth. As the earth spins, it causes the currents to curve. Instead of going straight, you can see in on the right hand picture, the blue is going straight. This is not talking about cold and warm. The blue would be showing a normal movement of the current, but because the earth is spinning, we're going to follow the deflection, which is the red. Imagine if you're on a merry-go-round. Let's say we have two people on the merry-go-round, one on either side, one on the end on the left, one on the end of the right. Well, if you're not spinning, you can roll a ball. Let's say there's no post in the center, but you can roll the ball to each other. It would go straight, right? But let's say you have a friend, a third party, start spinning you. Okay, so both of you are spinning on the merry-go-round, and you roll that ball. Well, that ball will curve off and not reach your friend who's on the other side of the merry-go-round. That's this idea of the Coriolis effect. Because the earth is spinning, okay, wind and water will now deflect or curve, okay, to a different direction. Okay, it will curve clockwise in the north and counterclockwise in the south. Okay, so you can see here now we're going to be focusing on warm and cold currents. You can see that here, okay, the different movements of water. So here is a current, a movement of water, bringing warm and then cold water. So here we have bringing up a lot of the cold, salty water as it moves. Definitely by the equator, it's going to be bringing warm water. Okay, as we said, in the northern hemisphere, it's moving clockwise to the right, and in the southern hemisphere, because the earth is spinning, it's going to be moving counterclockwise to the left. Okay, three things you need to know for surface currents. We have migration of animals. If you ever watched Nemo and the little turtles following the currents, this is going to be migration. Sailors use currents for navigation, and also very important in the impact of weather. Some currents you may be aware of: rip currents, upwelling currents, and density currents. Rip currents are the most common. A rip current is basically when the water is going to be moving towards the shore. And remember, this is different from a wave. This is now a current. And many times we call this a rip tide. It is not a tide. We'll talk about what a tide is in a second. But you have basically water being brought into the shore on the left and then the right, but then they come in together and they bottleneck. And because they bottleneck, it's so strong, and many times if you're caught in a rip tide or rip current, it'll knock your feet out from underneath you. Then we have upwelling currents. Upwelling currents are going to be where you have wind going across the coastline, okay, horizontally across the coastline, and this brings water from the ocean floor, from the bottom up. This is going to bring cold water up. This is going to bring dead and rotting flesh and fish and different nutrients at the bottom. It'll bring it up, and it will actually provide nutrients for different fish or insects that are at the surface of the water. Then we have a density current. So a density current, this is something you need to know. There's two factors here: salinity and temperature. Salinity is how much salt is in the water, and then we have temperature. Okay, warm water is going to rise. Okay, just like warm air will rise. Cold water is more dense; it will sink. Okay, so with temperature, if something is cold, it's very constricted, very dense. It will sink. Warm water will then rise. It is less dense. It will rise. Now let's talk about salinity. If you ever heard of the Dead Sea, many people who travel to Israel, Jerusalem, they do visit the Dead Sea, and basically you can float in it. People try and push you down. You can't, because it is filled with salt, lots of salt, and so high salinity. Okay, it's going to be more dense. It will sink. So basically, that water will cause you to float because the salt water is more dense. Less salt water, though, it will be less dense and then it will float. And if you went into water that's maybe pure water, you would probably not float or as you would in salt water. Reading through this could save your life. Okay, here's a picture of the upwelling current that we talked about, and here's the density current. Okay, here's two terms that you need to be aware of. An eddy in the Gulf Stream. A Gulf Stream brings warm water from the Caribbean, from the Gulf of Mexico, and that's why they call it Gulf Stream, the Gulf of Mexico. It brings this warm water from Florida, okay, goes up the east coast of the United States. An eddy is like a miniature whirlpool. This is a circulating water. This is circulating water that pinches off from the Gulf Stream and creates these isolated little whirlpools. Now let's move on to the third one, a tide. A tide is actually caused by three celestial bodies: the sun, the moon, and our Earth. The gravity of the moon and the sun impacting Earth causes a high tide and a low tide. It causes an ebb and flow. Here you can see in the pictures about the different tides as the rising and falling of water. The low tide is called an ebb. The high tide is called a flow. A slack tide, slack meaning stopping, this is when the movement of water stops. When you have a difference between the high tide and low tide, that's called a tidal range. Okay? How much more will the water rise between tides? Now there is a bulge called a tidal bulge of the ocean water that is actually being pulled from the Earth. Not out into orbit or anything like that, but there is a bulge caused by gravity. There are two types of tides that you need to be aware of: a spring tide and a neap tide. Now the spring tide is when the moon, earth, and sun are lined up on a horizontal line. Okay, think about in the spring you hang your clothes on a clothesline. It's horizontal. It's all in a line. This happens 2 times a month. And here we have the neap tide. Think of neap sounds like your knee. When you're sitting in a chair, your knee is bent. So the moon is in a right angle compared to the moon, earth, and sun. So you have the moon is in its first quarter and third quarter phases. This is called a neap tide. This also happens 2 times a month, usually impacting the tides by creating a low tidal range. Okay, and then we have some distances between the moon and Earth. When the moon is closest to the Earth, you have a pedigree tide. When the moon is further away, you have an apogee tide. The importance of tides will actually circulate water. It can circulate food, waste. It can also trigger spawning, the reproduction of different fish and crustaceans.